we'll go ahead with this. This is the course content for PLSQL for those guys who are, as I said, who are just a beginner, or we can say even the guys who are having experience of 1 or 2 years, but always have a confusion of whether we should do it not, or they always apply the hit and trial method during the development of their software. So that hit and trial method can survive them, but to the point, learning something to the point that actually matters a lot. It's instead of wasting your time in hit and trial method. So here we will talk about the brief introduction of the PLSQL. What is PLSQL, SQL versus PLSQL? What are the important tables we use while querying our data? Many people that they don't know how to check the different constraint available in a table. Suppose I created one index, I forgot the name of the index. I would like to check what was the index I created on the EMP table. Okay. 1 second. Yes. Yes, this course is actually Introduction to Oracle as well as PLSQL, both. Understood? So, and we'll come to know that writing PLSQL means what are the different tools we generally use to write our PLSQL code. Some are the licensed version, some are the open source. I'm using one tool which is called PLSQL Developer. This is look like this. SQL Developer is also same. SQL Developer is an open source provided by Oracle. You can download it from the Oracle site. And then after that, we'll talk about the basic structure of the language, PLSQL language, which constitute this PLSQL language, like what are the lexical unit, identifier, literals, executable, non-executable statement, anonymous block, types of variable, nested loops, and all. Means the basic entity which we are going to use before we learn the PLSQL. And obviously, like any other language, every language supports some data type. So we'll talk about the data type here in this particular chapter, and the control structure, nested loop. Okay, we'll continue it up to here. We are going to stop. I'm going to show you how SQL works internally in the Oracle DB. Let us have a look on this figure. I hope you can see this. This is a normal flow chart of how SQL works internally. These are very basic. I think even the people have written so many SQL, but many of them are not aware of how SQL works internally. This is the picture of SQL internal architecture. Before going into that, I want to show you one second. See, this is the basic SQL architecture. I'll talk about something about memory management. Here, everything, whenever you start the Oracle, so everything like any software will deal with the operating system and the memory. These are the basic requirement to install a software. So once the Oracle is installed, every software requires some amount of memory. That main memory of the Oracle is called SGA, System Global Area. Within the SGA, we'll talk something about shared pool. I'm not going to deal with everything like in detail of Oracle architecture, but our main focus would be the basic memory structure which is being used in the SQL execution. So you can see at the shared pool. Within shared pool, something called library cache. Here is our hit, like here is our target. Any SQL we write, it is getting stored here. You can see one SQL I showed in this example, select star from employee. The moment I execute select star from employee, it gets stored in this area. This is called shared SQL area. Before it going to execute, Oracle first check whether someone else from the other session has executed this particular SQL or not. If it is executed, now you see this diagram. Now you'll come to know this particular diagram. Execute SQL statement. First it check this statement was there in the library cache or not. If it is there in the library cache, then we call it soft parsing. Any language has a compiler. Compiler does the main primary job of the compiler is the parsing. Then where every syntax are getting checked, every semantics are getting checked, and finally from top to bottom, if everything is all right, Oracle says this particular set of code or piece of code has been compiled. We call it hard parsing. For example, I'll show you here. For example, I say declare begin and I'll say end. If I declare one variable called I called integer, they'll see in detail. I'm just showing you what is soft parsing. Or better we write the SQL statement. Select the star from EMP where ename like Smith, S-M-I-T-H, Smith percentage. So the moment I execute this SQL, so Oracle will first check this select statement is written properly or not. That is spelling check. And we call it syntax, means we cannot give a space between SEL and ECT. So it should be a complete keyword. We call it keyword. And after that, there should be a column name. I cannot write table name like this. So this is, and the more important thing, since I logged in with a Scott schema, so Oracle internally checks also this schema, this user has sufficient privileges to access this table or not. This is called semantic check. So any reserved word checking is actually called syntax check. Any accesses on the database object is called semantic check. So during the parsing, Oracle mainly does two activities. One is syntax checks, second is semantic check. This is called hard parsing. So the first time when one SQL is going to be executed, then Oracle does the hard parsing. That is why I am checking it. The first time that SQL will not be there in the library cache, that is for sure. I'll show how to see the library cache. So that is called hard parsing. The first time it is going to be stored into the library cache. So obviously this particular SQL I executed, it was not there in the library cache. We will check how to see that. So the complete hard parsing is there. Once the SQL statement is hard parsed, Oracle internally prepares the execution plan for each and every SQL statement. We call it statistics of the Oracle, statistic of the SQL statement. Oracle internally prepares the statistic. You have to help Oracle to prepare the statistic by using analyze table. We call it analyze table. Analyze table name, we call it compute statistics. This was introduced in Oracle 7 onwards. Nowadays with Oracle 10G or 11G, this became very advanced. I'll show you. I'll give this session while in our one of the chapter called It's SQL tuning, basic tuning tips. Nowadays, these people are using one package called DBMS underscore stats dot gather table stats, something like this. We'll talk about it separately. Either you can use analyze table, EMP, compute statistic. The moment you say compute statistic, Oracle try to find all the resources internally. It will check whether the CPU has sufficient core to execute your SQL. It should not be busy enough. Is there any parallel jobs are happening within the CPU? All the CPU cores are free or all the CPU cores are busy. Depending upon that, it's same like that. If I have a 5 people group of main 5 people who are going to execute my work, so I have to check internally whether all the 5 people are available or some of them have already got some assignment. They are working on something. So I have to keep eyes on those guys. Whether they are free, depending upon their free or their availability, I will pass my job to one of them, or it is me that who has to think like who is more capable to do what. So I can split my job among 2-3 people also, depending upon my requirement. That is called I am planning the statistic for my job. Same like Oracle also does like this. Always treat this Oracle, the database is nothing beyond this word. It is from this word only. So all the activities it does in a real life, Oracle try to make it more intelligently. That is called Oracle CBO, cost-based optimizer, is a partial intelligent optimizer. They call it AI, artificial intelligent optimizer. So it always try to find out the best plan to execute my SQL queries. Very optimized one, or you can say shortest path to reach to the destination. Oracle, so they call it execute plan over here. So once the plan is ready, now your SQL statement need to fetch the data. So once the moment you fire the SQL, that has been done hard parsing. After that, plan is associated with that particular SQL statement. Now, after the plan is ready, Oracle will hit into the file, database file. From the database file, it will fetch the data, actual data into the buffer cache. We call it buffer cache. So the actual data information will be stored into the buffer cache. So we check it again whether the data is available there in the RAM or not. If it is available, it will fetch. Otherwise, it has to read the data block from the disk. It's stored into the buffer cache. You should understand like data logically is stored into the database blocks. We call it like, I'll show you, we can say like this. One second, I'll draw one figure. Insert table. This will be in the form of like this. One information will be stored in one cell. Second information will be stored in second cell. So we can say like maybe this particular block, this block is having 1, 2, 3, 4, 5, 6, 7, 8 cells. By default, if we don't declare any number of cells, Oracle take it 8-byte data block by default. When we configure the Oracle database, internally Oracle sets every database block size is 8 KB. Each block will have a kind of cells over here. One cell, second cell. Each cell may having 5 records, 6 records. That depends how Oracle does it internally. That is not our job to understand. But anything, any information, actual physical information, if you are talking selected star from employee, it must be coming from one of the cell of this database block, one of the cell. So in order to show the data, this whole cell should be loaded into the memory. So Oracle tries to load this whole cell into the memory, which we call buffer cache. This is called buffer cache. So you can imagine if the SQL is already there in the library cache, if the data is already there in the buffer cache, how fast your SQL would be. So If you think like sometime you are executing a complicated SQL that takes times to fetch the information, not this example, and telling if your SQL is having 8 tables join, 9, 10 tables joins, if you'll see in the first time if you execute the SQL, it takes some time. The moment you execute second time, it won't take time. It show you the result immediately. Here you can say 0.016 second. Here you can say, I'm showing the mouse hovering on this 0.0616 second. Now try to execute it again. Again it is taking 0.6. Third time it is taking 0 seconds. Okay, this means it cached the information, it cached the data into the memory. Let us log in as a sys user in order to find the library cache. New instance, and call it sys. You won't be having the permission to log into the sys user. You can ask your DBA, or at home if you have a database installed, you can try yourself. There is Oracle has given one data dictionary views. We select star from v $SQL. So from here, I'll show you when we actually start the session. Let me show you one thing. SQL underscore text. So any SQL which we write will be stored over here, where SQL text like I'll say same thing which we executed over here. Ename. We'll search for this word Smith. See here, I've used this particular thing. So select star from even the SQL statement we are looking for from the library cache, that will also be cached. See, select star from AMP, there is Smith, ename like a Smith. So the next time then we execute the same SQL, it won't insert second record over here. As you can see, we can only see one select statement over here. But the moment I write something in capital letter, only select in capital letter, how Oracle behaves, I wanted to show you here. Same select statement, it is going to fetch same one record, but Oracle says like these two SQL statements are not same. See here, this SQL statement and this SQL statement. So Oracle inserted both the SQL statement in the library cache because Oracle internally is a case sensitive. That doesn't show to us, but internally it is a case sensitive. This select statement are not identical in Oracle perspective. So it again go for the hard parsing. So that is why in every company the people says like always try to follow the coding standard of a company, of the organization. So people always say if you are writing any keyword, always write in capital letter. If you are using any table, always write in capital. Similarly, so that if someone has executed the same thing 1 hour before, and if you are trying to execute the same thing, that should not undergo for the hard parsing. That should be already available there. So the Oracle call it soft parsing. If some SQL statement is already checked, parsed, authentication has been verified, like this particular Scott user is having the access on this particular AMP table, means all syntax and semantic is checked. So you can save your time while doing that syntax and semantic. Here, since this is very small SQL statement, here you won't be finding the difference between these two SQL data fetching time. So, but if you will be firing in a day around thousands of SQLs, then that matters. This syntax matter. So you always should have a practice of writing the SQL statement in the same case in the same cases, like either you use in uppercase or lowercase. So like other memory, this memory area is also a finite one. Finite in the sense like nothing is infinite in the computer. There must be some memory of 16 GB RAM. So if you fired the SQL statement in the morning, that may not be available in the evening, so that there are many queries which have been fired during the day. So Oracle will always try to store which is the least recently used. They call it LRU, or we call it first in, first out. In this same example, if someone has written something 34 here, suppose I have used something here, I have used something here, I have used something here, I have used something here. So there is no space to enter an different data, or there is no space to enter the another data. So this data must have to go away from the memory, and these all need to be shifted here. These all need to be shifted here. Similarly, Oracle does the same functionality inside the library cache. So the new information will always be stored here, new info. This is called least recently used, will always be here, or the first in, first out. This guy earlier came earlier, so it has to go from the memory. So it is always said that shared pool size. Here I showed you shared pool size. This is called shared pool size. In $V parameter, Oracle has a tuning parameter also. Shared pool size makes a lot of difference in execution of your SQL. If your SQL statement is very complex, taking a lot of time, you go and increase the shared pool size, you will see the big difference. But there is a calculation behind increasing the shared pool size. So I hope this is sufficient to understand. Let us focus on the course content once again. So in this basic PL SQL architecture works same like as SQL execution, same thing, everything is same. So here also, instead of SQL statement, I would say execute PL SQL statement. Same functionality behind this. Every PL SQL statement is also need to be cached in the library. So here in this particular course content, it is very, one second, yes, it's the same thing. So this is going to be very much helpful for the beginners as well as who are having 2-3 years of experience, as I told, because you would be, being an experienced guy, you may be knowing some of them, but in every session we will talk about some tips and tricks. Also, maybe you might not came across that tips and tricks, simple things. Suppose for example, yesterday I faced a problem like, if you are going, I have written one simple select statement, select EMP. One second, I'll show you the so here every day we'll come to know one small information, but it would be very useful. Select from EMP and department, where EMP dot department number, the EPT number, is equal to DEPT dot department number. The moment you choose any column from the employee table, say EMP dot, first select EMP dot EMP number. Let us execute this query. Let us see the explain plan of this table. This table is going for the full table scan. Even there is an index on department table. Why? So if you execute this particular, we say that if you are using any index column on a table which is having the primary key or the index column, it shouldn't go for the full table scan. But in 11G, you will find a big difference between 11G and 10G CBO, cost-based optimizer. Oracle treat is to go for the full table scan if you don't select that index column name over here. So similarly, we will be seeing every day a new tips and tricks in every session. We cannot write everything over here. It will become like a 10-page course content then. So lexical, working with a different data type, people always get confused with the date data type. People always say, shall we write? In my office also, there are many juniors like say, why to-date is not working? I want to display data in a different format, MMDD, YYYY. I want to select, I want to find on the first Sunday of every month. How do we find? Because the requirement was like this, so we will play around with the date, time, and the intervals. Or suppose the server is there in the US, and someone from the India want to see the time of insertion of particular data. Suppose someone opens an account in a bank in US, and the guy, another branch, Citibank has a branch in US. Okay, so obviously the database server is in the US. So every time capturing will be local time of the US, and some Indian Citibank guy would like to see the local time. At what time this guy opened the account. He would not be concerned about the US time. So you have to, being a developer, you have to write a code such that from wherever the country the Citibank is, Citibank will always see the local time. So how to manipulate the US time with the local country time we'll be seeing over here. There are many realistic examples we'll see here. The Boolean type, the character is string type, number type, LOB type. This is very much important data type that nowadays the people are using, because Oracle is becoming internet-based software nowadays. PLSQL, you can design your PLSQL code server page also. We call it PSP, like a JSP. So they are making this PLSQL very much powerful nowadays. So there are a lot of demands in PLSQL. There are a lot of openings in PLSQL because of so many new features which were introduced in Oracle 11G and 10G. So nowadays, whatever Java can do or any browser-based language can do, PLSQL also can achieve the same thing in a fastest way. The main important of using the PLSQL is the optimized. If you try to do something using the Java, it may take time because finally the data is going to be fetched from the database server. Here PLSQL is a server language, so you no need to traverse your code, no need to traverse from client to server again and again. You can execute everything if you have written in the PLSQL procedure and function at the server end itself. So you will save a lot of IO type, input output operation time. So at 5 we'll see the control structure. That is most important because this nowadays the people are using this case statement. Suppose the requirement is like this. I would rather say requirement is like this. Select, very simple requirement. Select star from EMP, order by department number. The moment I say the order by department number, Oracle will display the information based on department number in ascending order. You can see all 10 department number are appeared there. Now you can see all 20 department number is appeared here. Now you can see all 30. So all department number are displayed here in ascending order. If someone says no, I want the ascending order, then you can write it on. But the actual catch is, see here, 30, 20, 10. If someone says, no, I want the department number 20 to be displayed first, then 10, then 30. Then how would you achieve it? Then we will achieve it by using the case statement. The case statement, we will see in what places we use the case statement. Can be used in the select statement, can be used in the where condition, we call it the predicate. It can be used in the order by clause as well. So we would be seeing very magical things over here in the control structure. Similarly, we go to statement and null statement. Nowadays, Oracle guys in 11G, they introduced a new feature called continue. It was not there earlier. If you find like something need to be executed again and again, you can say go to and continue. This was not there earlier. So if someone will ask what are the new feature introduced in Oracle 11G, you can say like this is continue word was introduced to do this functionality. It is one of the new feature which you came to know now itself. So there are many new features we will be coming across, we will be seeing during the course session in 11G and 10G. simple loop. They'll talk about the iteration, like the same SQL statement if need to be executed again and again depending upon the business logic. Then we can talk about those things in a different types of loops. We'll talk about a simple loop, while loop, for loop, labels, scope of rules. It is a very, very important topic. Like you declare some variable, till what time this variable value will be there in the database. We'll talk about the scope of a variable here also. Exit statement, this is very simple. This is also going to be very much useful topic, is the exception handler. How to handle the exception, especially in case of when we are dealing with a huge volume of data. Suppose we want to process around 1 million of records and we don't want any kind of interruption. If any error occurs in the 1 million, so don't stop your execution there. I just instruct the Oracle save exception. Save exception is used during the bulk collect. So all the erroneous record will get stored into one of the audit table, and we will see at the end of our process, like how many of them get stored there in the audit table as an error table, the reason of the error table, and all details. We'll talk the different topics tomorrow. So we are stopping it here for the timing. There are around 12, 14, 17 are there. 17 topics are there. All are very much interesting topics. Pipe function, pipeline function, how to make your function in parallel, how to make a function so that the function itself will be behaving like a table, like select star from function name fun and your parameter. So have you ever seen that function is behaving like a table? If you'll see, like this particular function will not be there in that table list. We call it table function. We will see it in a different session. And at the end, we are talking about the case studies. Okay, case study means during my experience period, whatever the things I learned so far, they'll be helpful to you. We will talk about in this particular topic. I'm going to unmute you guys. You guys can ask me your queries and concerns.